Module 21 is dealing with two-sample proportions. Remember we talked about the binomial distribution and proportions. With proportion, remember we had to have sufficient size so that we could get the accuracy and not have to use the binomial table. This is setting it up as a proportion. Now, if two people go out and test a product, okay, and they come back with different results. They could have taken separate sample sizes and come up with different proportions. If we're asking, are the proportions different? Okay, we're comparing two people's work. That is a two-sample proportion. Okay, let's take a look at, I want to just take one example. Let me set this up. Okay. Okay, this was pulled out of the old text. All right, set it up like that. All right. This was a problem in which we were looking at an English text, and they were looking for signs of gender bias in terms of the references within the text. Okay, and so what they did is they set it up and they looked through the book and they came up with how many times was an adjective used referring to a female, how many times was an adjective used referring to a male. And we had 60 females and 132 male. Now, of that, they recorded how many times it was a juvenile reference, like girl as opposed to woman or something like that. So X is how many juvenile references. We had 48 out of 60 for the women, and 52 out of 132 for the men. And what they wanted to test was the proportion significantly greater for the females than for the males, which would be indicative of things. Okay, now, since this is proportion, first thing we got to do is calculate the proportions, but we got two. Okay, so females, 48 over 60 gives us 0.80. Now, this is not a parameter, this is a statistic, because this is from our actual work. So we put a cap on the top to indicate that this is the proportion that we calculated. We put a sub F to indicate that it's the women. Okay? And then we do the same thing for the men. 52 out of 132 gives us 0.394. Now, Q is related to each one. So if P sub F is 0.80, Q has got to be 0.20. For the men, we get 0.394. Subtract that from 1, I get 606. Okay? And the numbers were what? 60 and 132. So the problem here now is how do I compare these? Okay. What I'm going to do is I'm going to subtract 0.80 minus 0.394 and divide by the standard deviation. The problem is which one? Because I've got two different populations here. Remember, the standard deviation would be P times Q divided by N. Well, how do we combine these? You combine them by the following formula. Let me gotta zoom in a little bit so I can show you. Okay, what I'm going to do is, this is P for the female times Q for the female divided by N for the female. This is P for the male times Q for the male divided by N for the male. And so I do P times Q divided by N. I did that and I get 00267. Then I take 0.394 times 0.606 divided by 132. I get 00181. Add them together, I get 0048. Then I take the square root of that, and I get 067. That is my combined standard deviation for the two-sample proportion. Okay? Let's go back over that. P times Q over N for one sample, PQ over N for the other. I add them first, then I take the square root. Okay? Now, doing my test. Let's just slide down here. What do I have? .80 was the female, minus .394 was the male, divided by the standard deviation. This gives me a Z number of 60597. Remember, this is normally distributed, so this is a Z test. If I'm testing at 95%, I'm going to compare against 1.96. 6.059 is way, way, way over that. Okay? So I would reject the null hypothesis and accept the alternate hypothesis. So I could say I'm 95% confident, I'm over 95% confident that there is significant difference. Okay? Or significantly greater if I was testing on a one thing. To do it 99%, I'd be comparing against 2.574. And so I'd have the same conclusion. Really, 6 standard deviations, this would give me a p-value of 0.0000. So I could say that I'm over 99.99% confident that there is difference in this. Okay? So that this would give us evidence that the author was using gender bias in their thing, in the use of male and female adjectives in their. Okay? That's how we do it. Let me put that up again just to make sure you get it. The standard deviation is the tough thing to do. P1Q1 over N1, PQ2 times Q2 over N2, add them together, then take the square root. So I take P1 minus P2, divide by this number, and that's my calculated Z number. And then I just compare that against a table number of 1.96 or 2.574, depending on what I'm testing at, and I've got my answer. That should be fairly easy to do by this point.